Hello everyone, welcome to my channel Middleware Technologies. Today we are going to look at how we can set up AWS Gateway API Controller on Amazon EKS. So here in this video, we will try to understand how we can install and configure the AWS Gateway API Controller implementation to provide service to service traffic routing in the EKS cluster. So that is what we are going to basically implement in this video. So I'm going to install the Kubernetes cluster of the latest version using the Amazon EKS feature, and we are going to use that one to set up the Gateway API Controller further on top of that one. So now let us try to understand what is Gateway API. So if you go into the Kubernetes documentation, so Gateway API is the latest superset project of the Ingress controller. So basically it provides us with a entry point from the external of the cluster into the Kubernetes environment to route the request to the appropriate services. And Gateway API is basically enhancement, we can say, to the Ingress controller because it is much more mature. It has a set of specifications. It has a set of custom resource definitions that are provided based on the roles that are defined in the organization. So it is much more enhanced and mature. So that is why even if you go into the Kubernetes documentation, they suggest us to move to Gateway API instead of Ingress controller to provide to use the layer 7 and layer 4 level of routing into the Kubernetes networking. So as I said, Gateway API is a set of specifications that are defined as custom resources and are supported by many implementations. So Gateway API is basically a set of specifications which are implemented by different providers which we can use. And here in this video, we are going to use specifically the AWS API Gateway API Controller, which is an implementation of Gateway API specifications. Now let us try to understand what are Gateway API resources. So as I said, there are three main API kinds that are provided as a part of this Gateway API specifications, and they are the gateway class. So gateway class is basically it defines a set of gateways with common configuration, and there is a controller which actually implements this gateway class. So whichever gateway is using this gateway class as a parent will get that common configuration, and it is going to be controlled by the gateway controller that implements that class. And gateway, the second API kind, it defines an instance of traffic handling infrastructure. So basically it is an entry point into the Kubernetes infrastructure, such as it may be a cloud load balancer or a proxy bus server within the Kubernetes environment. And the next one is HTTP route. Basically it consists of rules that define how a particular request needs to be routed into the appropriate service in the Kubernetes networking environment. So these are the very high level API kinds that are provided by the Gateway API, which we need to extend and use in our Kubernetes infrastructure in order to implement the networking feature. Now let us try to understand the AWS Gateway API Controller, which is an implementation of the Gateway API specifications. So the AWS Gateway API Controller, it is an open source project. As I said, it is a superset project of Ingress Controller, and currently it is the project that is being developed by the AWS side, and it is fully supported by the Amazon. So AWS Gateway API Controller integrates with the following services, that is Amazon VPC Lattice, and allows you to manage the following communication. So there are two communications that are managed or that are provided by the AWS Gateway API Controller. So the first one is it handles the network connectivity seamlessly between services across VPC and accounts. So this is very important feature that is provided by the Amazon VPC Lattice that integrates with the Amazon Gateway API Controller. So Amazon VPC Lattice can integrate with services that are deployed in different VPCs across different accounts. So with the Amazon VPC Lattice that provides a high level entry point to all the services that are deployed into different VPC networks and accounts. So that is one very important feature that is provided by this Amazon VPC Lattice. And the second one is discover VPC Lattice services spanning multiple Kubernetes cluster. So we can have a Kubernetes cluster that is deployed into different accounts or different VPCs, and those also can be discovered using the VPC Lattice services. So these are the two features that are provided by the Amazon VPC Lattice, specifically that integrates well with the AWS Gateway API Controller. Now let us try to understand the high-level architecture that we are going to implement in this video. So we are going to deploy a set of pods in the AWS EKS cluster that will provide the following services. So basically we have a review, parking and inventory services exposed in the Kubernetes environment, and these services will get the request from VPC Lattice. So basically VPC Lattice will have an entry point to these services. So there will be a service network that will be an entry point which will have the following services registered, that is rates and inventory. So whenever a request comes to this service network VPC Lattice from, let's say, the VPC environment of EKS cluster, it goes to the VPC Lattice service network, and here the request gets routed to the appropriate service that is registered with this following service network. And once the request reaches the Lattice service, it will try to identify the HTTP route based on the context, and it will identify the appropriate target group where the request needs to be routed. And these target groups which are created in the VPC Lattice target group will route the request appropriately to the Kubernetes services which are available on the EKS cluster. So this is the very high level architecture that we are going to implement in this video. Now let us go into the procedure of this implementation. So as a first step, we need to have some set of CLIs and utilities installed on our workstation, from where we will be creating the VPC Lattice services and the AWS EKS cluster. So for that, like the first thing is we need to have the Amazon AWS CLI client installed on our side. So if you followed my previous video on how to use the EBS volume on the Amazon EKS cluster, like you can see like how we have installed all these utilities. So I'll not go through all these steps, so I'll just show you. Like I have AWS CLI already installed, so this is the version that I have installed. And the next thing, like we need to configure it with the account that we have on the AWS. So once that is done, the next step is to set up the kubectl. Kubectl is used to manage the AWS EKS cluster. So I have already installed that one. Kubectl version will provide you with information about the kubectl that is installed. So once that is done, we need to ensure that we have the AWS EKS CTL is also installed. So AWS EKS CTL is going to be used to create our AWS EKS cluster. So it is basically used to manage the EKS cluster. So I have EKS CTL version, the following version installed on my side. Now step 4, we will install the JQ, that is JSON query package. So this is already installed on my side. So if you do DNF install, it will show that already installed on my side. So you can just install it on your side as well. So that is already installed. So let me clear my screen. Now the important step is set up the AWS region and the cluster name as environment variables. So here, like we will be using the US East 1 region to set up our cluster, and our cluster name is going to be kubestack. So these are the two environment variables that we are trying to set up so that we can use it in further commands. So let me just copy this command. So it will set the environment variables for region, and the other one is going to be the cluster. So now let me clear my screen, and now let us go to step 6, that is creating the cluster. So here, like we are going to create a AWS EKS cluster with the backend worker nodes based on AWS EC2. So this is the command that we need to run in order to create that cluster. This is going to take some time for the cluster to get created, so let us wait for it. So I see like I have an error. It shows like CloudFormation stack failed because there are a few services that are already created on my side. So let me delete it and try to recreate it. So I have cleared my all resources that were created as a part of the EKS cluster creation, and now let us try to recreate the cluster. So now it has started creating the cluster. Let us give it some time. So now my EKS cluster has been created. So as you can see, the last message shows it has been created in the following region. So let me clear my screen. Now let us go to our documentation. So the next step that we need to do is we need to install the Gateway API Custom Resource Definitions, that is CRP. So this is the required step because we want to configure our AWS with the Gateway API implementation. So before that, installing the appropriate controller, we need to have these custom resource definitions installed on our cluster. So let us try to install that using the following kubectl apply command. we are installing the standard channel gateway API CRD files. So my custom resource definitions are installed. So as I said, on a high level, we have gateway class API kind, we have gateways API, we have routes APIs, that is one for TCP level routing, that is gRPC routes, and the other one is HTTP routes, and we have reference grants, that is for special cases that we are not going to look at in this video. So these are the CRDs that gets installed. So let me clear my screen, and now let us go to our next step, that is step 8. So here, like, what we need to do is we need to allow the traffic from Amazon VPC lattice to be routed to the EKS cluster. So EKS cluster is basically built in a particular VPC, and it has a specific elastic network interface that is attached to the cluster. So what we need to do is, first we need to identify the security group that is attached to this EKS cluster control plane and master nodes. Once that security group is identified, we need to attach or allow the IPv4 prefix and IPv6 prefix for the VPC lattice to the security groups ingress rules. So let us see like how we can do that with the following commands. So the first command that I am running is to capture the security group that is attached to the cluster. So once that is done, so you can just do an echo and you will get the security group ID, and the next step is to identify the prefix list ID for IPv4. So let me copy this command. Let me clear my screen here and let us copy this command. So what we are going to do over here is we are going to identify we are going to use AWS EC2 describe managed prefix list, and from there like we will try to pick up the VPC lattice prefix list ID using the following command. So let us try to run it, and you can do echo prefix list ID to check whether the prefix list ID has been captured. So this is the prefix list ID for the IPv4 prefix, and now what we are going to do is we are going to update our security groups rules. So we are going to update the security group ingress rules, allowing the following prefix list ID. So in the IP permissions, like we are going to provide the prefix list ID, which is the prefix list ID that we have captured in the previous step. So let us try to update this one, and as you can see, the prefix list ID has been added to our ingress rules. So let me clear my screen. The next step is identifying the prefix list ID for IPv4, IPv6. So here So let me copy this command. So as you can see, we are using the same command ec2 describe managed prefix list, but here specifically, like, we are going to look for prefix list name ending with IPv6 VPC lattice. So we will need to identify the prefix list ID for IPv6 VPC lattice, and we need to update our ingress rules. Let me run this command, and the next step is updating the ingress rules. So here we are using authorized security group ingress, and we are providing the IP permissions with the prefix list ID for IPv6 to be allowed, and this is the group ID that is the security group that we need to update. So let me run this. So our ingress rules have been updated. So let me clear my screen. Now let us go to our next step, that is creating an IAM policy. So here, like, basically a IAM policy is a set of permissions that we want to provide it to a particular identity. So that identity can be a specific user or a specific role that can be assumed by a specific service. So we will try to see, like, which identity, like, we are going to use, or which is going to use this policy and assume the role. So first, before that, let us try to do a curl to get the policy. So this curl command is going to download the policy, that is a JSON document file, into the following file name. So sorry, so let me remove the $sign over here. Now let us try to run it. So the policy document is downloaded. So let us try to go through that document file. So these are the actions that we are going to allow as a part of this policy document. So basically these are the permissions that we are giving to the following resources. So the effect is allow, and similarly there are other statements. So like IAM create service link role, and IAM create service link role for the AWS service role for VPC lattice and AWS service role for log delivery. So this is the policy document file that we will be using further in order to manage our VPC lattice services. So now let us go to our documentation. So now that we have downloaded our IAM policy, the next thing that we need to do is we need to create that IAM policy using the document, the policy document that we have just downloaded. So we are going to create a policy with the following name: VPC Lattice Controller IAM policy. So basically the controller that we are going to create in the further steps, like it is going to assume this policy document with the set of permissions that we have defined, so that it can manage the VPC lattice resources. So that is all that is going to be happening. So now the policy has been created, that is VPC Lattice Controller IAM policy. So let me clear my screen. Now the next step is we need to identify or capture the ARN for the policy that we have created. So for that, let us try to run this following command. So we are going to list the policies, and from there we are going to run the query to identify the policy name, and from there we are going to capture the ARN for that policy that we have just created and export it into the following variable. So now the variable has been captured, so you can do an echo in order to identify the ARN that has been captured. Now let us go to our next step, that is step 10. Create the AWS application networking system namespace. So here, before installing the controller, that is AWS Gateway API Controller, what we are doing is we are going to create a particular namespace, and we are going to use that namespace in order to create our controller. So for that, let us try to apply this YAML definition file in order to create our namespace. So the namespace has been created. You can just do kubectl get namespaces to see the namespace has been created. So this is the namespace AWS application networking system that has been created just now. So let me clear my screen. Now let us go to our next step, that is step 11. So step 11 is set up the pod identity agents. So pod identity agents is a feature that helps to provide the credentials to the pods which wants to communicate with the AWS services. So here, we need to install this pod identity agent, which will install the pods onto all the nodes that are available on the AWS EKS cluster, and these agents that are running by the workloads to communicate with the AWS services. So for that, what we need to do is we need to first create an add-on. So here, we are going to create an add-on for our cluster. The add-on name is going to be EKS pod identity, and the version that we are going to use is the following one. So let us try to run it. And next, you can see, the following pods will be created. So as you can see, the pods are running in the respective nodes. Now let us go to our next step, that is step 12, create a service account. So here, we are going to create a service account in the namespace Gateway API Controller that we have created previously. So this service account is going to be used further by the controller that we are going to install in that specific namespace. So we will see further in the next steps. So before that, let us try to create this YAML definition file. Let me clear my screen, and let us try to create our YAML definition file, and let us apply that YAML definition file to create the service account. So the service account has been created, and it is going to be created in the respective namespace. Now let us go to our next step, that is step 13. So here, what we are going to do is we are going to create a trust policy document file. So the trust policy document file is basically a file which contains the service that is going to be allowed to assume a particular role with which this trust policy document is attached. So for that, first we need to create this trust policy document file. Let me clear my screen over here. So here we are creating a trust relationship .json file, wherein we are going to allow the following service only to assume the role with the permissions, or the policy document with the specific permissions that has been attached to that role. So the policy document, the trust relationship document file has been created, and now what we are going to do is we are going to create a role, and we are going to assume we are going to attach this assume role policy document file to that role. So let me copy this command. So let me run it over here. So here, what we are going to do is we are going to create this role, and we are going to provide attach this trust relationship policy document file to this role, so that this role, whoever is going to assume, so this role is basically going to be assumed by that specific service that has been defined in this trust relationship document. So as you can see, the IAM role for API Gateway Controller for VPC Lattice. So let me create this role. So the role has been created. Now what we are going to do is we are going to attach the policy document file that we created previously to this following role. So let us try to run this following command. So here, we are going to attach role policy. So this is the role that we just created, and this is a policy document ARN, which has the set of permissions that can be assumed by that specific service that can assume this role. Okay, so let us create this one. So now let us try to export that ARN for the role. So this is the VPC Lattice Controller IAM role ARN that we are capturing. So we can just do echo that variable, so it will provide us with the IAM role ARN. So let me clear my screen. Now let us try to go to our next step, that is creating the association. So here, we are going to associate the VPC Lattice Controller IAM role that provides the required permissions to manage the VPC Lattice to the pod identity to the pods. So this VPC Lattice Controller IAM role is going to be associated with the following service account that we have created in the AWS EKS cluster in the following namespace. So the controller that we are going to install in this particular namespace is going to use this service account, which is internally is going to assume this role, which has the set of permissions to manage the VPC Lattice services. So we are going to run this command to create that association. So let us try to run this command to create that association. So the association has been created. let me clear my screen. Now it's time to install the AWS Gateway API Controller. So the step 15 is to install the AWS Gateway API Controller. So for that we are going to apply the following YAML definition file, which is going to install the controller in that specific namespace. So now the controller installation has been completed. So you can verify it in that specific namespace. So let me do kubectl get force -n. So the namespace that we have created is going to be this namespace, AWS Application Networking System. So let us try to see like what is running in that namespace. So you can see the Gateway API Controller is running in that particular namespace. So let us try to do kubectl get logs in that particular namespace. So our names, so the controller has been successfully installed. We are not seeing any errors, and it is able to communicate with the EKS cluster. So let me clear my screen. Now let us go to the next step, that is create Amazon VPC lattice gateway class. So the first object or the gateway API class, gateway API kind object that we are going to create is the gateway class. So let us try to create that one. Using the following apply command. So you can see the gateway class has been created. So you can just do kubectl get gateway class, and the gateway class name is going to be Amazon VPC lattice. So let us try to do get gateway class and output in the YAML file. So this gateway class that we have just created is using the following controller, that is Application Networking KX AWS Gateway API Controller. Okay. So now let us go to our next step, that is clone the git sample repository. So here like we are going to use this sample repository, which contains the kubernetes workloads that we are going to create on the AWS EKS cluster. So let me just do a clone of this. So I have this project already cloned, so I can just go into this following location and the resources will be available. So now let us try to go to our next step. So the next step is create VPC lattice service network. So here like we are going to use the AWS CLI in order to create the service network named My Hotel. So let us try to create that one. Let me clear my screen. And now what we are going to do is we are going to associate that service network with the VPC, that is the EKS cluster VPC, to allow the communication from the VPC which is holding the EKS cluster to send the allow the traffic to be sent to the VPC lattice service network. So for that, first we need to identify the network service network ID for the service that we just created. So that is, so VPC lattice list service network. From that, we are going to identify the network ID for the My Hotel service network that we just created, and then we are going to identify the VPC ID for our EKS cluster, and then we are going to run this association command for associating the VPC lattice cluster VPC, the service network, with the VPC ID. So the association is created. So you can list the association. So that is in progress. Now let us go to our next step, that is create the Kubernetes gateway, that is My Hotel. So here, so gateway, as we know, like it is an entry point for handling the traffic. So basically it defines a network endpoint that can be used for processing traffic, that is filtering, balancing, splitting, etc. for the backend such as services. So gateway may represent a cloud load balancer or a in-cluster proxy server that is configured to accept the HTTP traffic. But in this case, like we are creating a gateway that is an entry point which is a VPC lattice service network which is external to the EKS cluster. So let us try to create this gateway. So the gateway has been created. So you can just do kubectl get gateway, and it is going to show you the gateway that has been created. Now let us go to our next step, that is step 20, create the Kubernetes HTTP route that can match a particular path routing to the parking service and a review service. So here, like we are going to apply two deployments, that is the parking.yaml file and the review.yaml file. So let us try to apply that one. So it has created the deployment app and exposed it as a service, and we are going to do the same thing to apply the review.yaml file. So this is also going to create the deployment and expose it as a service. So if you go to kubectl get pods, you will see the parking and review pods running, and you will get to see the following services also created, that is the parking and the service. So we have deployed our deployments and created a service in order to access it within the node port. But now, like what we are going to do is so before that, now we have another route that we need to apply, that is So here, like what we are going to do is we are going to create a route. So let me show you like what we are going to apply. So let me output this in the format of YAML. So this is a HTTP route gateway API kind. So as you can see, it uses the parent reference, that is the gateway, that is my hotel, and the routes that are defined in this HTTP route are as follows. So if there is any path matching the following context, it is going to route it to the following service, which is listening on the following port. And if it is going to get a request for the following path matching, it will route the request to the following service, that is the review, that is listening on port 8. So that is the HTTP route is all about. Now let us create another deployment. Let me clear my screen. We are going to apply the inventory version 1. So it is going to create the following deployment and the service. Now let us create the HTTP route definition also for the following service. So we can just look at the HTTP route, that is inventory, output in YAML. So here, like you can see, it uses the parent references, that is gateway, my hotel, and the rules that are defined under these HTTP route are as follows. So whenever there is a request for the following context, it is going to route it to the following service listening on port 80. Now let us go to our documentation and let us go to our next step, that is step 22. So we have already completed step 21, that is creating the HTTP route for inventory service, and now let us try to identify the DNS names for the HTTP routes that we have just created. So these are the two HTTP routes that we have created. So in order to identify the DNS names that has been assigned to the following routes, so let us try to look for rates, output in YAML file, and you will be able to see the following annotation: lattice assigned domain name. This is the domain name that has been assigned to the following HTTP route. So that is the rates default, the following ID, VPC lattice service in the US East on AWS. So this is how you will be able to identify the domain name that has been attached to the HTTP route. So you can just do a similar command to the route inventory, and you can see the inventory domain name assigned. Now let's clear the screen. So now let us go to our next step, that is we have already completed. Check VPC lattice generated DNS address for the HTTP route, inventory and rates. Now let us go to our next step, that is step 24. Store the VPC lattice assigned DNS names to variables. So we are going to use the following two variables to capture those domain names for the rates and the inventory. So we can use echo to get the name. So this is the FQDN for rates and this is the FQDN for inventory. Now let us go to our next step, that is step 25. So this is where we are going to verify the communication between the services that we have just created, that is the rate services that provides the parking and review context, and the inventory service, that is the separate service. So let us try to access the rates services, that is parking and review, from the inventory deployment. So the request goes to the following pods, that is parking and review. So this request, the curl request that we have just triggered, it goes through the VPC lattice service network, which will identify which service is servicing for the parking and the review, and it is going to route that request appropriately to the service that is deployed on the Kubernetes cluster. Now let us try to identify the connectivity between the parking service to the inventory. So we are going to reach the inventory service from the parking deployment, and this is going to reach out to the inventory pods. So as you can see, it has reached out to the inventory pods. So our communication has been successful. So now we can confirm that the service to service communication is working as per the expectation using the VPC lattice service network. So this is how we can implement the AWS Gateway API Controller, which provides us with the HTTP route management for the Kubernetes services. So that is all I wanted to show you in this video. I hope you enjoyed watching this video. Thank you all. Thanks for watching this video, and you guys have a great day.